Hello students, in this session you will learn about solving a problem on designing a constant K high pass filter. In the earlier video you might have seen a similar kind of an example to design a constant K low pass filter, but this is now designing a constant K high pass filter. So let's take this example into consideration. Design a constant K high pass filter network having cutoff frequency 1 kHz and design resistance 1000 ohm. So let's start solving this. So we will firstly note down the given things. The given things are cutoff frequency FC is equal to 1 kHz or 1000 Hz and the value of design resistance R0 equal to 1000 ohm. So further we know we should calculate the value of inductance to be employed in the filter network. So value of inductance can be found out in case of high pass filter with the formula R0 upon 4 pi Fc, which if evaluated comes out to be 79.6 millihenry in this case. Further we should find out the value of capacitance involved in the filter network. So value of capacitance can be found out using the formula C is equal to 1 upon 4 pi R0 Fc. If all the values or the values of R0 and Fc if are substituted, we get the value of capacitance as 7.96 into 10 raised to minus 8 farad. Now once we obtain both the values L and C, we are supposed to design or draw a filter network, a high pass filter network, both in T symmetrical type and in pi symmetrical type. So let's draw it. So look at this. This is a T symmetrical type or T type constant K high pass filter, what we precisely call it as far as exam is concerned. So the things to be noted down carefully and differentiated from low pass filter are, look at this, series arm is made up of capacitor in case of high pass filter. In case of high pass filter, the series arm is made up of capacitor, whereas in case of low pass filter, the series arm is made up of inductor. I hope you remember it, which was shown in the earlier video. And the shunt arm in case of high pass filter is made up of an inductor, whereas in case of low pass filter the shunt arm is made up of capacitor. I hope you will remember this difference. Now we have got the total capacitance to be equal to 7.96 into 10 raised to minus 8 farad. So see, in series arm we have got two capacitors to be included. This is the standard circuit we know. So two series capacitors will be equal to the value C only when 2C is connected in series with 2C. So that is why you have to double the value of capacitance that you got when you decide the value for this capacitor. Similarly, you have to write double value of this capacitance when you write the value of capacitor over here. So it means it is 15.92 into 10 raised to minus 8. Similarly, this is 15.92 into 10 raised to minus 8 farad. Now as far as inductance is concerned, a shunt arm branch is consisting of only one inductor. So L must be equal to what is obtained in during the calculation. So this is how you got T type constant K high pass filter. Now we will find out a pi type constant K high pass filter. So this is what you should get over here. So as I said, in case of high pass filter, series arm is always made up of capacitor. In case of T, it is made up of two capacitors. In case of pi, it is made up of only one capacitor. In case of T, the shunt arm is made up of only one inductor. In case of pi, the shunt arm is made up of two inductors. So one capacitor obviously then must be of this value. But when two inductors are to represent one shunt arm and they are connected in parallel, as if they are connected in parallel, then it is possible that you will get an equivalent inductance of L only when twice L is connected in parallel with twice L. So twice L parallel twice L will always be equal to L. So if you want 79.6 millihenry as an equivalent inductance, then you should connect 159.2 millihenry in parallel with 159.2 millihenry. So this is how you should write it, 2L and 2L. So this completes the design of a constant K high pass filter. You have to keep in mind the differences between T type constant K high pass filter and T type constant K low pass filter, pi type constant K high pass filter and pi type constant K low pass filter. As I already said, the difference was the elements in the shunt arm and the elements in the series arm and elements in the shunt arm. Okay, thank you.